Because it's better to see.
Alright, so today we're looking at periodic phenomena, and we're looking at describing the characteristics of a periodic function, which is a function that repeats itself. Here we see an example of a periodic function, and what we need to do is to add 2 additional periods. So in this periodic function, we're told that the period is equal to 4. That means the function will repeat itself every 4. So if we look at the distance from here to here, we're going from -1 to 3. This is +4. Here is +4. This is the period of the function, which means the period in which it repeats itself. So this function is going to repeat itself again here, following the same pattern, and then it's going to repeat itself again here, following the same pattern. This is a periodic function. What's interesting about this one is the function is going to equal 1 every 4 numbers as we increase. So here we have a similar type function, not quite the same one. A portion of the graph of the periodic function g is shown. What is the least possible value of the period?
-5.
Have a look at the function. What is the least possible value of the period? How long does it take for the period to repeat? 5.
So it's right.
So the distance from here to here is 5. But likewise, the distance from that point to that point is also 5. This is 5. This is our period. When we say the least possible period, could there be a different period for this function? Not 5.
Yeah.
What would it be?
The whole thing.
What would another possibility other than 5 be for the period?
10.
10. Could there be anything else?
15.
15.
All multiples of 5.
All multiples of 5. It's going to repeat. So this is the least possible value for the period, but we could say that the period is longer and it repeats itself every 10. So using the example given in number 2, we need to evaluate it now. So we're going to try now and evaluate the function. Ooh. So our period, the period is equal to 5. So we're going to use this now in order to evaluate the function. I'm going to do the first one for you. We need to figure out what g of 14 is. Now, unfortunately, 14 is about here on the graph, and we can't see what it is. But what you can do is you can remove periods, because it will repeat itself every 5. So the way we can do this is if we consider integer division. If we take 14 and we divide it by 5, what is the answer?
So, I mean the answer is...
If we divide 14 by 5, what do we get?
2.8.
We get 2, if we do integer division, we could say 2 remainder, how much?
4.
So using integer division, we can say this is 2 remainder 4. So if we divide 14 by 5, we can say that this is equal to 2 lots of 5, remainder 4. And we can take all of the integers, all of the integer multiples of the period away, leaving us with just 4. So g of 14 is going to have the same value as g of 4. In the same way that this point here is going to have the same value as this point here. We can take away multiples of the period. So all we have to do now is find where g of 4 is. So g of 4 is here, so this is going to be equal to 7. Have a go now at B and C for yourself.
Right.
So let's have a look at our next one.
7 pages.
For B, we've got g of 72.
Third page. We have 4 pages.
We can obviously take off the 70. We can take off the 70. That is 14 lots of the period. So that is going to give us the equivalent of g of 2. G of 2 is 6. Another way to work, like with this this next one where we're at minus, where are we, minus 17, is you can just keep adding or subtracting multiples of the period until you bring it into the right place. So I can add 10 to this, because 10 is 2 periods. That would be g of minus 7. I can add 5 to it, g of minus 2. I can add 5 to it, g of 3. All of these points will be the same. So you can just bring it closer and closer until you get it into the interval that you want. Once we have g of 3, we can read it off. This is going to be 7. Using that technique now, have a go at this question for yourself.
Not.
All right, let's have a look.
There we go.
So for the first one, we're told that our period is equal to 5. So if we take h of negative 2, we can add 5 to that, and we're going to get h of 3. We can see that 3 is available here, so this means it's going to equal 0. Let's try the second one. The second one is h of 6. We can start by taking 5 off of that, and it gives us h of 1. That's in the table, so this is going to be negative 2. These two are fairly straightforward. Then we have this composite function. We've got h of 9. So FRQ1 almost always has a composite function question. You're usually given 2 functions, one in the form of a table, one in the form of a graph, or one in the form of a formula, a function rule. And you're given 2 of those 3 choices, and there's always a composite function. So here on this one, we need to use a composite function. It is a periodic function this time. So we need to find h of 9. So let's take off 5 from 9. That's going to give us 4. So that would mean that this is equivalent to h of 4. 4 we can find in the table, and the answer is 3. So this is going to be h of 3. So h of 3 we can find in the table. That means the answer is 0.
Does my handwriting look like a font?
Yeah, it's pretty good.
Yes, that's me.
Any questions on that?
If it was h of 2, can we also add
Oh,
or
I did
subtract 5 from the second one?
Yeah. Yeah. If it came out somewhere that wasn't in the table, we could then move it until it was. You could, so we're hitting at the basic idea of periodic functions, an idea that they repeat themselves. You can remove multiples of the period from the number. So we can use that basic idea here in this question. So this is a generalization. This is a generalization of the concept. So our period is 5. So 5k, doesn't matter what k is, it's a multiple of our period. So no matter what it is, we can just remove it. So this is our basic idea. You can always remove multiples of the period from the number, and it simplifies it down. Once we get to minus 3, we can try and bring it into this by adding a 5. If we add 5 to that, we get 2. 2 is not in the table. The table's not complete. We add another 5 to that, will bring us up to 7. 7 is in the table, so the answer there is 2.
So what was k again?
An integer, a whole number.
Wait, sir,
An unknown whole number.
How did you get rid of k?
Because the period is 5, 5k is clearly a multiple of 5.
Yeah.
And the whole idea of this lesson so far is when evaluating a periodic function, you can add and subtract multiples of the period to the number that you're inserting into the function.
What if
So 5k is a multiple of the period, so we can ignore it.
what if there wasn't 5k, it was like 4k?
Then you have to be clever and figure something out.
Wait, so because it's 5k and 5 is the period, then it can't, it basically is removed. Okay.
If it's 4k?
If the period was 4, you'd be okay.
And if it was 3k?
If it was 4, it'd be like,
If it was 8k and the period was 4, you'd be okay. But they wouldn't ask you a question you couldn't do. That would be mean.
What if they did and you have to solve it by saying, no thing? Okay.
So we won't be put in a scenario where like the one attached attached to
I need
a
to end it
variable isn't a multiple of the period? So like, let's say the
Probably not.
okay.
Probably
Give me
not.
that.
Will we eventually learn
You're
how
like
to?
putting it in your mouth.
No, it's like here.
No, I literally saw it. I
I
saw it
think I
caress
could
your
maybe
legs.
come up with some kind of a scenario where you could factor around until you find a
I'm
multiple
watching
of
you
the
and it's
period.
doing
It would
this.
still be the same answer. Sorry, can we have quiet on that one? Shh. Let's have a look at the last question.
Just keep it away
Now
from
this
the
last
open.
question, this last question is the challenging one. This one is very challenging. Let's have a look at this. So we need to find h of k is equal to -2, where k is a number less than or equal to -17, k is an integer. So in order to get -2, we have to be working with this part of the function. We have to be working with this part of the function. We can say that, so k has to equal 1, or not. Does it have to equal 1?
No,
No.
not necessarily.
The only thing that we can put into the function to get out -2 will be that k with bit k has to equal 1 plus multiples of of n. So any number which is 1 plus 5n, where 5 is the period, will produce -2. The only thing that can get us to this red part here in the table is if we put in 1 plus 5 multiples of 5. Now that's not going to work because we have to now make this adjust to be a number which is less than 17. We need a number which is less than 17. So what values of n can we use? We can't use n equal to 1. We can't use n equal to 0, but there must be some values of n that will work.
Does it have to be less than 17 but more than 1?
K has to be less than 17. But what values of n will produce k so it's less than 17?
It's -17.
Sorry, less than -17.
So then you have to do 1 plus 5, whatever that equals, and then anything just less than -17 minus 6.
What do we get?
-4 or anything less.
-4. What's going to happen when n is -4? What will k equal if n is -4?
-19.
Sorry, work it out for yourself.
It's negative now.
What will happen if n is equal to -4? You'll get -20 plus 1, -19. So n has to be anything less than -4. What are the complete set of values of k? So this expression here can be used to define all of the possible values. You can write it like this. This would be k is equal to -19 plus 5n, where n is less than or equal to 0. The same expression. You can write this as k is equal to -19 minus 5n, where n is greater or equal to 0. All of these are the same expression. You can put it up as a set of actual values. So you could have -29, -24, -19. We can show that as a set notation, as a cascading sequence. It's going to stop here at -19. You can't get a number bigger than 19, but you can get multiples of 5 smaller than 19. So any of these forms can be used to express your answer here to this question. You can see a worked solution of it here. Take a minute or two to copy this one down, read it through. Okay, so the graph of f is periodic in the domain of real numbers.
It's going to be so
2 full periods of f are shown. Find all the input values of f that yield an output value of 1. So firstly, we have to identify the period of this function. What do we say the period is?
4.
So
You're going to be doing hard things.
p is
No,
equal to
next year's
4.
going to be easier.
Then we find the
Doing
first
more APs this year.
the first x value that will give us an output value of 1. So we can see that f of 2 is equal to 1, which means that f of 2 plus any multiple of the period is also equal to 1. Where n is an integer. So just read the question. What do we have to do? Find all the input values. So all our input values, inputs of 2 plus 4n,
AP line
where
we take
n is
tomorrow,
an
that's
integer,
That's
will
fine.
yield
This is
On
just,
Thursday.
this one is supposed to be the AP problem. I
1.
didn't know it was on both units. I would have studied earlier if I
Sorry,
knew.
what was the?
God, I started Sunday.
It means n is an integer.
It'll be fine.
But I thought if it was on unit 2, we
So-
just need unit 2. So it's
It's positive or negative?
This symbol here means is an element of. This symbol, the double stroke z, is the set of integers.
If I had known earlier, I would have studied.
In this particular case, they can be positive or
If I'm
negative.
even allowed to take the
If you wish them just to be positive integers, you put a little plus sign.
Sir, can you go back just?
Did I spell her name right?
Sir, for the exam semester
Have a go now, our exit ticket question. Have a go now. Okay, so firstly, we can see that the function repeats itself so that the period is equal to 4. So we have p is equal to 4. It repeats itself every 4. We have the interval 39 is less than x is less than 41. I can subtract 40 from this. So if I subtract 40, which is 10 periods, I'll get minus 1 is less than or equal to x, which is less than 1. I'm going to leave it like that, and I'm just going to continue this graph here to minus 1. And I see that from minus 1 up till 1, the function is going to be rising all the time. And that means I'm going to choose B as my correct option. Okay, that's it for today. Have a go at the classwork.